Let us continue our discussion. After discussing virtual memory using various diagrams from Hamacher textbook and Morris Mono textbook of computer organization, we are moving forward to a topic by name performance consideration. So here we are speaking the performance consideration of a machine, of a computer. So performance considerations as is better performance and better performance with a lower cost, and better performance is dependent on what? Faster access of the data and the instructions, and speedier execution of the programs by the CPU. That's how performance improvement happens. So always for commercial success of any product, especially computer desktops, computer laptops, or computer computing machines, strategy for better price performance ratio is stride for. What that indicates, the performance should go on increasing, but the price should not increase as the performance is increasing. It should be either stable or constant, or not that high. So how do we achieve this? So there are multiple ways. One way is the way memory hierarchy is designed, right from main memory to cache memory to secondary memory, their role play. So their speed of executions and their interrelationships, how the data is moved from one memory component to another memory component or to the CPU. So it means what? A memory hierarchy, which we had discussed previously, plays a big role in this topic called as performance considerations. Let us not forget what is the meaning of performance here. Performance indicates how fast my system is, how fast it accesses the data and the instructions, how fastly it executes the programs, and that performance we want at a reasonable price or at a lower price. That is what is the objective. Now, for this objective, let us not forget memory hierarchy plays a bigger role. Now, along with memory hierarchy, we know that in the memory hierarchy there are few memories which are faster, there are few memories which are slower, like auxiliary memories may be slower than the cache memories, registers may be faster than the cache memories, and so on and so forth. Now there is a movement of data and instruction from these varying speed memory equipments. What do we do now? What ideally is desired is the movement should be faster. Now, this faster movement as well as the faster execution can only be achieved through parallelism. Now, activities can be parallel, tasks can be parallel. This parallelism can be achieved with the help of a memory adjustment called as interleaving. So, when we are speaking about interleaving, we are speaking about memory interleaving. And when we are speaking about memory interleaving, what we are actually doing is we are designing, we are structuring our main memory in such a way that that main memory is divided into separate modules which are part of the same memory, but separate modules are there, and each separate module will have its own memory address register and data register. Here the nomenclature may vary. They may not be called as address registers and data registers, but they may be called as the ABR and DBR registers. So the diagram which you are looking at is the example wherein memory interleaving for parallelism is achieved. Now, why parallelism needs to be achieved? Because we want a better price performance ratio. And why better price performance ratio is required? For the commercial success of, say, desktop or a laptop or any computing machines. So all these aspects come under what topic? All these aspects come under topic performance considerations. So let us look at this arrangement. What we are seeing here is our memory, right? Now our memory is divided into module 0, module 1, module 2, and so on and so forth. So here whatever we have written about memory interleaving is justified in the diagram. What we have written in here, what is the meaning of memory interleaving? Memory interleaving means divide your main memory into modules. Have we divided our main memory into modules? Yes. Each main memory here, a main memory is divided to module 0, module I, module n minus 1, and each module has a separate ABR and DBR, which are the address registers, address buffer register, and the data buffer register, which are analogous to your address registers and the data registers, memory address register, memory data registers. So in this arrangement, if you look at the this diagram number is 5.25 from Hamachara textbook. If you look at this diagram, the A component of the diagram, what it says is, suppose this is my memory address, right? In this memory address, the first k bits indicates which module. So am I going to select module 0 or module I or module 4 or module 10 or module n minus 1? Which module to be selected, that will be determined by the first k bits, the leftmost k bits, or you call it them as MSBs. Now once you select the module, within that module the next m bits will be deciding the which address in that module, which address, which location in that module. So here what will happen is the reading of the content in the memory modules is say top to bottom like this, and at one go only one module is referred, at one go only one module is referred. There is no uh, concept of parallelism being achieved, there is no concept of interleaving being achieved. If you look at the second diagram 5.25b, so here what is happening is the arrangement is slightly changed. You can see here the k bits are determining the modules which are now on the right side. The leftmost m bits are deciding the addresses in the modules, the leftmost m bits are deciding the addresses in the modules. So with this arrangement, what is happening is simultaneously at one go we may access multiple modules, and in those multiple modules the accesses of particular address lines will be happening. So this can be the example of memory interleaving. This memory interleaving requires 2 to the power k modules, 2 to the power k modules, and here we know what is k, right? That k determines the module number. Let us say 3, so it will be determining 7 or 8, 0 to 7 modules. So like that, and this entire effort is for what? This memory interleaving, understanding the concept of memory interleaving is for what? Memory interleaving is for parallelism. Parallelism is for faster execution, faster data access, and it is for better price performance ratio. And better price performance ratio is considered under the topic performance considerations.